In the rapidly evolving world of artificial intelligence, developers need robust tools. For the Kotlin ecosystem, a new contender has emerged. JetBrains Koog is a native AI agent framework. It is designed from the ground up to leverage Kotlin's strengths: conciseness, safety, and strong support for asynchronous programming with coroutines. Koog is not just another library, a strategic platform. It aims to make building complex, stateful AI agents into a structured and manageable process. A clear path for Kotlin developers to enter the AI space without leaving their favorite language. Modern agents do more than call an LLM. They orchestrate services, databases, and decisions. This guide will walk you through Koog's core concepts, setup, and production patterns. By the end, you will understand why Koog is poised to become an indispensable tool for Kotlin teams. At the heart of JetBrains Koog lies the strategy graph. This is the fundamental concept that shapes how you design and build agents. A strategy graph is a directed acyclic graph, a DAG, defining an agent workflow. Each workflow is composed of two primary elements: nodes and edges. Nodes represent individual units of work, self-contained functions or operations. A node might prompt an LLM, retrieve data from a database, or call an external API. Edges connect nodes, defining control and data flow through the graph. Edges can route to different nodes based on outcomes: success, retry, or error handling. You can trace execution through the graph to understand why an agent made a decision. Modularity and reusable nodes make complex systems maintainable and scalable. Koog provides pre-built nodes but allows custom node creation using idiomatic Kotlin. Need a new LLM or data source? Replace or add nodes and reconnect edges. Teams can work on different parts of the strategy graph concurrently. This plug-and-play architecture reduces complexity and accelerates iteration. Before building with Koog, ensure your development environment is ready. Koog requires JDK 17 or higher. Use Gradle for first-class support, or Maven, both are supported. Add the Koog bill of materials to simplify dependency versions. Maven users add equivalent dependencies to pom.xml. Declare core modules like Koog Core and Koog Strategy Graph. The official docs provide copy-paste snippets for both build systems. Koog is model agnostic and uses connectors for providers. OpenAI, Anthropic, Google Gemini, or a self-hosted model provide API keys via environment variables or a secrets manager. Do not hardcode keys. Use a dedicated secrets tool like Vault or AWS Secrets Manager. Define your first strategy graph using Koog's declarative Kotlin DSL. Koog supports many agent designs, starting with the simple agent. A simple agent follows a linear or lightly branched workflow for tasks like Quanda or summarization. Use it for text summarization or data extraction. A typical graph: capture input, format a prompt, call an LLM, then parse output. Complex agents handle multi-step tasks with conditional logic and multiple external systems. For instance, a travel agent checks flights, books hotels, and searches attractions via distinct branches. Memory is critical. Koog supports short-term and long-term memory. Short-term memory persists across a session. Long-term memory stores facts across sessions. Integrations include vector stores for RAG and traditional relational databases for facts. Add validation nodes after LLM calls. If invalid, route to correction and revalidate. This validation correction pattern improves reliability in production. Start simple, add memory and validation, then evolve into multi-step graphs as needed. Koog integrates tightly with IntelliJ IDEA for a fluid developer experience. Enjoy code completion for the DSL, easy navigation and standard debugging tools including breakpoints. Build with Gradle or Maven and integrate into CI/CD like GitHub Actions, GitLab CI, or Jenkins. Run unit and integration tests in CI to catch regressions early. Package your application as a jar and containerize it with a standard Java runtime image. Copy the jar into the image and define the run command. Deploy on Kubernetes for orchestration, auto-scaling, and self-healing. Configure auto-scaling and load balancing to handle traffic spikes. Design Koog apps as stateless. Store state externally in Redis, vector DBs, or databases. With containers and standard CI/CD, deployments become repeatable and reliable. Before production, implement observability, OpenTelemetry, secret management, and automated tests. With these practices, Koog scales from dev laptop to enterprise clusters reliably. Testing is essential. LLMs are non-deterministic, so Koog promotes a layered testing strategy. At the base, unit tests with Koog test mocks that return deterministic responses. Simulate successful model responses to validate happy paths. Simulate malformed outputs to test validation and correction handling. Simulate API errors to test retry and circuit breaker logic. Write tests that assert the graph structure. For example, ensure a validation node follows every LLM node. Structural tests in CI prevent regressions when multiple developers edit graphs. Use test containers for integration tests against real databases or services in CI. E2E tests are costly. Focus on a few critical happy paths with rate-limited real LLMs when needed. Combine mock unit tests, graph validation, integration, and targeted E2E tests for resilient agents. This testing strategy gives you the confidence to run Koog agents in production. Security is paramount when building AI agents that handle sensitive data. Add a moderation node at the start to filter malicious or unsafe input. Never hardcode secrets. Use environment variables or a secrets manager like Vault or AWS Secrets Manager. Read secrets at startup and separate code from configuration. Implement data retention policies and consider regulatory requirements like GDPR and HIPAA. Add anonymization nodes to scrub PII before sending to LLMs. Sanitize outputs to prevent leakage of internal URLs or sensitive data. The explicit graph makes auditing and tracing easier. Log node execution and data transforms. Combine input moderation, secure key management, anonymization, and output sanitization to build compliant and secure Koog agents. Koog is friendly for solo developers, fast onboarding and quick prototypes. Small teams can start with a single strategy graph to deliver value fast. As teams grow, split logic into subgraphs so teams own domain-specific workflows. Publish reusable node libraries as Maven or Gradle artifacts for organization-wide reuse. Establish governance, approved libraries, authentication standards, and compliance checks. Avoid fat nodes and tangled edges. Prefer small, focused nodes and subgraphs. Use modular subgraphs, shared libraries, and CI validation to scale reliably. With careful design, Koog supports teams of any size building complex agent ecosystems. Koog arrives at a pivotal moment for the Kotlin community, bringing a Kotlin-first approach to AI agents. It leverages coroutines, strong typing, and an idiomatic DSL for safe, productive development. The ecosystem is growing. Start with a small pilot, instrument thoroughly, and contribute back as you learn. Koog offers a compelling Kotlin-first path to production AI agents. Try a pilot project today.